Hi, everyone. Tonight we have Chris Butler. Chris is Director of AI at Philosophy, where he leads the firm in human-centered AI engagements. Chris has over 18 years of product and business development experience at companies like Microsoft, Kayak, and Waze. He first got introduced to AI through graph theory and genetic algorithms during his computer systems engineering degree at Boston University. Please give Chris a warm welcome.
Thank you. Thank you, everybody. Thank you. Yeah, so I'm Chris Butler, Director of AI. My background is product management. How many people here are designers? How many people are data scientists? What about engineers or, okay. Any product people? Yeah, okay, a few, cool. So yeah, what we're gonna be talking about today is teaming humans and machines. And when I say machines, I really mean, AI, which is the most hyped up thing. Well, sorry, one of 3 hyped up things that we're betting on right now. We're not gonna talk about blockchain, we're not gonna talk about AR or VR right now. But I will be talking about what is AI. I wanna talk about what is teaming, and really from the standpoint of HCI, human-computer interaction, maybe the idea of how are we going to do a better job of creating systems that people can actually use. And then I have a couple things that I think are really key when building these types of systems, and then I'll talk you through a couple exercises and methodologies that we use to do this at Philosophy. So first, what is AI? And we'll try to do that in about 5 minutes. And I usually like to start in what it is not, because I think there's a lot of misconception about what artificial intelligence, machine learning, and even data science is. And so first thing is it's not just chatbots, right? There are other things besides chatbots that you can build with these types of technologies. It's not magic fairy dust that you can spread over something and then suddenly it's a better system in some way. It's probably not the Terminator or the Singularity. We won't know until it happens, so just don't worry about it. It's not going to be like Scarlett Johansson voice that we're going to fall in love with, probably. And it's also not so if you type in AI into Google image search, this is what you see. So a lot of blue glowing brains, a lot of kind of white plastic robots. But that's not what it is, right? It's not one thing, it's not one brain, it's not really that type of intelligence either. And so I think it's something that people, part of our job at Philosophy is actually to pull people back from what they're thinking because they see this all the time. This is the stock type of art that you see on every AI article. And then the next thing, when we talk about AI, we're really talking about automation in some way. So where there's a human that is taking a step back from owning something as a process, and not all automation is glamorous or even high tech. And so this is the case of the idea of the self-checkout, where this technology that was probably built 10 years ago, right? It doesn't involve any intelligence. If anything, it actually makes things worse for the people that are actually doing the checkout themselves. People are still employed, they're just helping people, they're basically troubleshooters for checkout people now. Right? And so this is what AI could be, essentially. And so what is it, right? I think David Robinson at Data Camp, which is a great way to learn online if you want to brush up on different types of data science or machine learning skills, has a really great breakdown because we're really talking about all 3 of these things, right? We're talking about data science, which is about producing insight. We're talking about machine learning and that class of algorithms that really is about predictions and classifiers. And then artificial intelligence really just means some type of action that is taken, right? And the way that we think about it at Philosophy, and I think there's a couple groups at Facebook and Google, and even other smaller companies that are really thinking about how do we apply things like artificial intelligence to human-centered goals. And so I just like looking at this from the standpoint of that data science is really about the insights of people, right? Machine learning is about predictions of what people will do or what they'll need. And then finally, artificial intelligence is really about taking action to help people towards some goal of theirs, right, or purpose. And you're going to be using a combination of these things a lot of the time. It's not going to just be one. Like you can't have artificial intelligence without having some insight about the way the world works. You probably can't do most artificial intelligence without having some type of prediction about what the future could bring. So with that as kind of setting everybody's kind of expectations about what we're going to talk about today as far as a set of technologies, I think that's a good enough start. So if you guys want to learn more, I'm sure there's a website out there somewhere you could learn. So teaming, what is teaming, right? This is an image from Figure 8. which is a group that does a lot of image for supervised learning, basically. How do they tag imagery? And so when we talk about the idea of teaming, especially when we're referring to things like artificial intelligence, we mean something that is referred to as human in the loop. And so that is essentially where, in some way, in this case, it's about creating some type of classifier. And so the classifier, if it's confident, it will go off and do something automatically. If it's not confident, it asks the human to help it out. And in the end, there's still some output that takes place, but it's about this idea that the human is helping it in certain ways that it doesn't know as much as it should, or doesn't feel confident in what it's doing. Chen-Hao Tan did a great Medium post that talked about the idea of, rather than human in the loop AI, the idea of machine in the loop. And so from the standpoint of that, rather than the machine being the main action taker, it's actually the machine that's helping the human then take action. And I feel like this is a little bit of kind of terminology or pedantry, I guess you could say, because the truth is that it's not always about just one human with one piece of technology in some loop. This is a great talk by Brad Klingberg, which I'm always going to butcher his last name, but he's the VP of Data Science at Stitch Fix. And so it's a really great talk that he gave where it's not just about actually one human being and one machine, right? It's actually about loops of humans and machines that are operating in a larger space. And so in this case, if you're not familiar with Stitch Fix, which actually I'm actually dressed with mostly Stitch Fix right now, but the idea is that the stylus is getting help from a machine learning algorithm to not only predict what a person would like, but also for a lot of other things. And so you start to see loops that are within this whole organization. And it's not just about single loops. This is a graphic that was done of interactions within Star Wars, right? And so the reason why I like this one is that there's actually machines that are alongside the different human beings. And so we shouldn't consider that it's just this one loop that's happening, but it's actually about organizations of humans that are then existing on top of some ecosystem of machines. Right? And these machines could be talking to other machines, but it could also be that humans are talking to other humans, which is what we usually do at work today. But it could also be that there's a chain of human machine, human machine, human machine for taking some type of action. And when we start to talk about the idea of human out of the loop, which is another term, and this is a still from War Games, which I don't know if anybody's seen, but this is the Whopper, which basically is a human out of the loop system where it would make decisions about global thermal nuclear war. And spoiler alert, if you haven't seen this movie yet, came out in '84. It does not turn out well by taking the human out of the loop. Right? Because the truth is that humans are always in the loop. It's just that in this case, the human that was in the loop was the entire world population that was about to get nuked. Right? And that really comes down to when we talk about systems thinking, is we're not drawing the system boundary correctly, right? When we talk about autonomous weapons, it's not about humans being out of the loop of autonomous weapons because there's someone that is being shot, right? There's someone that is impacted in some way, and if no one's impacted, then it doesn't matter what that machine does. It might as well not exist. So humans are always in the loop. Humans are always impacted. And so that means that when we're talking about machine learning, humans should always be setting the purpose of these systems. So how do we start to understand that environment that they exist within? And one of the techniques that we've used is something called rich picture, which comes from soft systems methodology. It was kind of the late 70s, early 80s. After cybernetics and system thinking really became popular, people were like, oh, our systems diagrams don't seem to make sense. There's these like squishy things that seem to exist within them, and they don't make sense a lot of the time. And so those things are human beings. In the case of rich picture, what you're doing is you're actually co-creating with people that know about the system. And so this is actually part of a case study that I'm going to walk throughout this entire talk that was focused on a particular organization that essentially repaired gas stations. And so this is a rich picture that we created with the team to understand how their business actually operates. And so there are a lot of things that even if we were to just solve one person's problem within this entire graph, there are n-order effects that would happen to other people within that graph. And so that's really important to understand. And so this case study, like I said, it was essentially a gas station repair company, 5 states in the Midwest. And we built a lot of different things for them, just as a quick note. So we did build a chatbot, which we failed at. And then we went in and we started building different types of field tech job management apps. We started building different dispatcher workflow systems. And all of these included either real or imagined prediction capabilities, automated decision making, and most of this was actually never built, like in real. So just as something to keep in mind. And I'll bring up a couple examples of this when I am walking through the different pieces of the examples. So the first of three things that I think are really important when it comes to teaming humans and machines is really around interpretability. And when we say interpretability, there's a discussion right now in especially machine learning about this kind of opposites of that. The more interpretable you want things to be, probably the more deterministic they are. And in this case, up in the upper left-hand corner, linear regression is probably the most simple way to actually do a prediction and then explain why to someone it actually happened. Once you start to get into neural nets, deep learning, it gets harder and harder to actually explain the particular reason why something happened. And I think this gets us into an issue with a lot of, this is the only Twitter joke I'm going to put up here, but it's a good one. It's about explainability, right? So mom says, why did you kick your sister? And the kid says, because my attention was on her. And the mom says, be more specific, because of the vector. Huh? C embedding 122, 0, 1, 13, 23. And so this is a machine learning joke, sorry. But what this really is about is that the explanation in this case is not helpful. Right? It's not helpful to the mom to understand why this happened. And so I think, again, I will be a bit pedantic in this case and say that it's not actually explainability we're going after, but it's interpretability. And there's a really great book that's available online if you want to read it. It's called Interpretable Machine Learning. And he goes through a lot of the technical aspects of things about how to make machine learning more understandable. But there's some really great sections about what makes a good explanation, which is related to some research that's been done, and then how do you start to understand examples. And so when we talk about the idea of good explanations, right, and this is really taken from a Miller paper, where what we want is a good explanation is something, well, first of all, is used by a human. Right? And so humans, the way that we operate, tends to be more along the lines of analogies and narratives and things like that. So the idea of being contrastive, like being able to tell this from something else, the idea of how does this relate to me in the world from a social standpoint. The coherent with prior beliefs is a very interesting one. So I guess an example of this would be that probably the most important feedback you have ever received has hurt, right? Because it actually questioned a lot of the assumptions you had about the world. And so the problem with explanations is that we want them to actually fit within the box of the universe that we have today, but the reality is that for us to really learn something, they have to not do that. And so it's a very interesting issue when it comes to things like interpretable. And I recommend reading this paper if you have a chance to. But there are really four ways that we can talk about examples when we talk about interpretability. And this is going to be a little bit more technical as far as the way that this works, but I'll get into what this means later on. So one of them is called counterfactual explanations. So this is an example that's used in a paper about Lyme, where this is a picture of a dog with a guitar. And what you would want to understand is that if it classified it as a dog or as a guitar or as both as a dog and a guitar, you want to understand maybe why it did that. And so what Lyme does in this particular case is it tries to take patches of the image and then say which parts of this image actually made me think it was this versus that. And so this is counterfactual. It's like, why, if I were to change one thing here, if I were to change this aspect right here, it would no longer be a guitar, right? So that's counterfactual. The next thing is adversarial examples. And this is a great example where this sticker, at least for I think some ImageNet models, where if you place this sticker near any object, it will suddenly think it's a toaster. And it doesn't really make sense to us because we don't see this. We're not understanding the way that the machine is actually looking at images or generalizing about images. But adversarial examples are really important because it tries to break down what the assumptions are of the world. And so, in this particular case, it's a sticker that makes the machine think it's a toaster, but it could be other things too. It's like the bugs or the edge cases in your system that don't make sense, right? That's what an adversarial example is. The next thing is prototypes and criticisms. So this gets to the idea that whenever you're talking to people, like if I were to ask someone, how do they do their job? Like if I had to start tomorrow, what would you tell me? They usually tell me that basically here's what you do, and that's the prototype, where it's like the standard way that things happen. But what you should watch out for is you should watch out for these other things, which are criticisms. And those criticisms tend to be things that are outside of the norm for a prototype. Right? And so when we try to understand things that are really good examples for human beings are, what is the standard thing I should assume? What is regular? And then what are the things that are not regular? What are the exceptions from that standpoint? And then finally, influential instances. So this is the idea that in data sets, there are sometimes cases where a particular example will skew the entire data set, and that example is very important. So a good story around that is, if you have a room full of 10 people and Bill Gates is one of them, the average income, the average wealth for that room is something like $1 billion. Right? But the truth is it's a very influential example to have Bill Gates in that particular data set. And so you'd want to know that it was 9 people that had maybe of average wealth from the United States standpoint and Bill Gates, rather than just 10 people that had an average wealth of $1 billion. Right? So that's where this idea of influential examples really come in, or instances. And this gets us to start talking about abstractions. And when I mean abstractions, it's originally a CS term, right? So it's this idea of that you have layers of abstraction that are taking you further and further away from what is actually happening. So you're no longer thinking about assembly code, ideally. You're no longer thinking about how you build compilers anymore. And in this case, they're talking about the idea of like a view or logical or physical. But it comes from computer science. But I think it's something that, when we talk from a design perspective, it's something we've started to try to understand is like, what is the abstraction of this information that helps me understand something better? And so the example that I like to use a lot is this New York Times article, which I don't know if anybody's seen, but it does a really amazing job at trying to simplify down how 2 particular MTA decisions about timing of trains has actually caused a lot of the lateness that we're seeing. How many people take the MTA here? All right, good. It's not a San Francisco crowd where everybody drives, so. But what was really interesting is when we talk about like abstraction here, right, you have to ask the question, like, what level of abstraction do we need? So from a policy decision-making standpoint, is it valuable for me to actually understand what it's like to drive? It could be, but it may not be. Same thing with this idea of like at these switches, and this is an actual switch, right? How does this actually work? And what is my job here? Is that a valid abstraction? Or is it this kind of central control abstraction? And in the end, it's actually none of these really, I think, would help you make this type of decision. And so what they came up with is a really, really amazing kind of interactive graphic where I'm able to play around with 2 dimensions worth of values for particular policies. And then I'm able to see on the right-hand side live, what does that mean when it comes to delays and stopping of trains? And so this is something that, they take the article to kind of walk you through how to read these things. But once you read this, these policy decisions make way more sense. And so if they had gone down that path to try to understand, how do they model this system, how do they create an abstraction of the system for policymakers, they probably would have made better decisions than they had already. So when we talk about abstractions, it's that balance, right, between complexity and usability. And that's really at the core of what a lot of design is trying to do, is it's trying to take an abstraction that's good enough that I don't have to be bogged down with the specifics unless they're meaningful. And then I'm able to actually gain some expertise there as well, right? And so good abstractions, right? This idea of minimum surface area for maximum volume, easy to use, easy to make changes. I think also this idea of separation of concerns is a really interesting one. So how do we make it so that we're not overloading abstractions with too many things that it should be doing? And this is maybe a great example of whenever you have like a dashboard, if you have 100 different things that are on a dashboard, right, it's not actually helpful anymore. Like I don't know what to look at, I don't know what to take action on necessarily. And so when it comes to my decision-making processes, the idea of separating out those things into better views makes a lot more sense. I've written a post about how dashboards are cowardly, but you can read that if you want to. And so in our case, this was an example of the field service operations dispatcher view. And there's a lot of things in here that actually were machine learning. So from the standpoint of this confidence level right here, it was an algorithm, basically a machine learning algorithm, to try to estimate the likelihood that this job, if it was assigned today, that it would be completed in one day. We ended up finding out through testing that the percentage was not helpful, right? But that's an abstraction for something that is very complicated in the back end. It's actually looking at all this data about past jobs. It's looking at the information about this current job, and it's trying to do a better job of like giving advice in that case. So that's an example of an abstraction. There were also some other things here about like how we hide away different things, like how do you recommend technicians, how do you actually create a flow of conversation that makes sense for people, and so that's just an example of that. The next major thing besides interpretability is really mental models, right? And the story I love to tell, of course, this is a designer group, so I have to talk about Don Norman and pray at the altar. So one of the things that I had found when I was going through a lot of kind of automation research, for not only for this talk, but for like all of the talks that I've done, came up with a story that was by Don Norman in the 80s, in 84, I think, is when this paper came out. And it was about mental models, and he tells a lot of interesting stories about calculators. And so in this particular case, how many people here hit clear on their calculator multiple times, like 4 times, maybe 5 or more? Okay. You know that memory does not work the same way on every calculator, right? Like the difference between a for function versus a scientific versus an accounting calculator, all of those things hold memory differently. But what we've done as people, right, is we've created a mental model about calculators that if we jam that clear button enough times, it will clear the memory and we'll be able to start fresh. We won't have any errors in what we're doing, right? So this is an example of a mental model that, while being helpful, is not true. Right? And so what he says in this particular paper is that, we must discard our hopes of finding neat and elegant mental models. And I think this is related to, any time that, we get a lot of pitches basically to rebuild Facebook. But besides that, we also get like the idea of, I really, really want to build this one perfect thing, and I'll tell you exactly how to build it, and I don't need to talk to anybody about it. And so whenever that type of thing happens, right, people build what they believe is actually logical for them, and that's their mental model. And it's kind of like you are not your user, right? The moment that you actually start trying to build something, you think about things differently, you make trade-offs differently. And so the truth is that this idea of a logical mental model or an elegant one is just not true, right? And so the last part of this is really that people are messy, sloppy, incomplete, and use indistinct structures when it comes to building these mental models. And so we should definitely understand that when we're building something that is maybe even the most perfect machine learning model possible, if people can't understand it and they can't build a mental model about how to use it, it's not going to be valuable. And so our models are not our user models. I mean, I hopefully don't have to say that to most people in this room because they're probably mostly designers, but I think it's a fallacy that we fall into all the time. Even if you are the actual user, you are still not the user because you're thinking about building something, just to be very clear. So how do we get at people's mental models? And there's a couple ways. So one is really around problem interviews. And if we're going to talk about it from the standpoint of machines, we need to ask different questions than just about their problems. Or maybe the way to think about it is there's some nuance that we need to get at. And so the first one is really stories. And so that idea of canonical stories really helps us understand how do people think about their job in general? How do they think about the way they interact with other people? How do you explain your understanding to someone else? That's how do they transfer these mental models between people? And then the last one is, really about trust, but what does it mean to do the thing that you do with other people? And how do you actually decide to interact with other people when you should or shouldn't? And I'll get into trust in a little bit, but that's really important. The next thing that we try to get at people's mental models is this is an exercise that we call empathy mapping for the machine, but it's basically a wholesale theft of Cooper's empathy mapping model. But from the standpoint of that, if empathy mapping for people is really about our assumptions about other people, like what do we think they understand about the world, or what do they feel, what do they want to do? In this case, empathy mapping for the machine is for some type of non-deterministic system or a system that's intelligent, what do we expect as human beings in the way that we interact with it, what it should do, and how it should actually perform? And so this is something that we've done. I've done a couple of versions of this as workshops here in New York as well, and it's part of like a basically design thinking for AI. But it's really helpful to get at people's kind of expectations and assumptions about the way the technology would work if it existed for them. The next thing is prototyping, right? Like I've already pointed out a couple of these things, but the idea of building a prototype is incredibly key, but it doesn't mean that you actually have to build the machine learning. Like all of the things that are up here that would require a lot of data and training to build out, we didn't build because we wanted to understand whether it was valuable to even have that functionality first. And then finally, we talk about synthesis of the research that we do after we've done interviews. And it's kind of hard to see what this is, but we basically, Leah, who's on my team, she came up with a really brilliant way to break out the different synthesis that we did around research. And so the way this works is that from this kind of vertical axis is understanding to not understanding what the machine is doing. Like, am I building a mental model where I think I understand what's going on? And then negative sentiment to positive sentiment. right? And so the things that you start to see is some interesting clusterings. So things that are below the line, this is where we did a poor job of building a mental model, maybe where we did a poor job of creating user experience or interface, or maybe requires some change management or something like that. So this is where we need to go back to the drawing board. The things that are in the upper right-hand corner, that's where people understood what was going on. They could build a model about the way that it was working, and they actually liked it. And so those are the things where probably we got that interaction right, probably we built that mental model right. And then the upper left-hand corner ended up being about, I know what it's doing, and I don't like that. And so some of it was kind of job security issues, but it got really to the idea of what do we believe humans should do, and what do we believe actually machines should do. And so there could be a case where a machine can do a job better, but it's meaningful for a human to do it. And so in those cases, we have to reconsider, like, is it worthwhile to actually get them out of that system? Like, are there enough errors where it's just bad, right? But at the same time, like, is this part of the job that even though it is maybe wasteful in some way, it actually provides, positive, kind of use for the human being in that. The last kind of three things I want to talk about is about trust. And so trust, this goes back to a story. I started a startup called Complete Seating, which was an open table competitor. And essentially, what we did was we made hosts and managers' lives easier, right? We did it, if I was raising funding today, it was basically AI for restaurants, but back then it was actually right before big data, so I think we were like BI for restaurants or something like that, whatever that term before the last one was. But what we do is we try to not only try to help automate a lot of the discussion that would happen before the person got to the restaurant, so automating, in my opinion, the right things, but then also trying to make the host really kind of the superhero of understanding how tables should be assigned and the flow of the restaurant should happen. So we did a lot of things with prediction of how long a reservation would take. We did a lot of different constraint programming or constraint optimization things around building out how a table should be assigned or not. And so we did a lot of really, in my opinion, smart things. And this is the example of this. This was before we moved over to Bootstrap, which had just come out at the time. And one of the things that we did, now that I'm looking back at it, is that this middle column right here, if it doesn't have a little lock icon, that was something that the system actually recommended as a table. And so we were able to get pretty good at a certain point. We were, I'd say like for 95% of the cases, we could assign the table that would work out best. There were definitely cases that it did not work. But what we realized and there were a lot of reasons why this company failed, by the way. What we realized by the end of it was that we had burned a lot of trust up front. So even just the simple things that we were trying to do, and we tried to do all of their job rather than just parts of it. And so we didn't allow them to start from the right point of trust. We didn't build trust over time. And that really hurt us in the end. Like, hosts started to basically lock in their own assignments for the tables, and it basically then caused worse problems when our system would try to work around the things that they did wrong, basically. So it was a big failure. And what this, when I was doing a lot of research around trust and automation, this is a paper by Parasuraman in '97. And it talks about 4 cases or 4 different levels or types of trust. There's 4 different cases, like use, misuse, disuse, and abuse, and all of those have to do with different types of trust or different levels of trust. And so the use is really that I'm willing to turn on and off this machine and use it when I should actually use it. Misuse is that I trust too much, and I turn it on when I should not be using it, right? When the human is the better option. Disuse is that I just don't trust it at all or not enough, and so I don't use it when I should. And then finally, abuse is about the idea that as an operator of a system, my needs are not taken into account, and only the designer or management is taken into account. And that's essentially like, if you look at the design thinking kind of 5 steps, it's basically removing the whole empathy thing and just building it, right? That's abuse. And an example that I think is really interesting is this is some work by Dr. Ayanna Howard down at Georgia Tech. And so she created a robot that is actually teleoperated, so it's not a real autonomous robot. But she would set up this case where students would be in a room, they'd be doing some type of false task, and then there would be smoke that would come into the room, there would be alarms that would go off, and then this robot would be in the hallway to try to take them somewhere from an emergency exit standpoint. And what would happen is that they found that even if the machine purposely didn't operate correctly, so in this case, the machine is just like going around in a circle in a room, the person would still follow them. And a lot of the time, even if they were trying to get them to go through a doorway that was blocked or all these things, the person would just trust the robot, right? And so in this case, there was too much trust based on the form factor that they had used, right? Because there's a real issue that when we talk about emergency, you want people to actually be scared a little bit because you need to get them out of the room or out of the building. And so in this particular case, probably a robot which was maybe be more calming, or they would trust more because it was something that was official, right? Maybe it shouldn't have been that. Maybe it should have been something else that was lower fidelity or something, Anyways, the point is that like when it comes to trust, it's about the right level, right? And I think there's something I recently discovered, which is brand new to me, but I mean, I went to the O'Reilly AI Conf in San Francisco a couple weeks ago, and 2 different speakers, like right after each other, referenced this NAP model, which is very interesting. And it talks about this idea of how you have escalating and de-escalating relationships between people. And so in this particular case, usually start with like initiating, where you first meet someone. Experimenting is then you start to find out like what do they like, what do they don't like, what do they do. You start to think about the idea of intensifying your relationship, where you're starting to make plans. You start to integrate your lives in some way. And then bonding is where you declare to the world that you're a friend or a spouse or something like that, right? And same thing with coming apart, is that there's like degrading over time. And so I don't think, I definitely have not done enough work on this model in particular, but what I think is really interesting is this is a lot like the way that we start to gain trust with machines as well, right? So we maybe download an app and we try it out initially and then uninstall it, right, for most cases. But then we start to think about like, what are the extremes of this? You can even see this with people with chatbots, like what are the things I can do and can't do with this? Once we start to think about incorporating this more and more in our lives, right, is it appropriate is the next question. Because yes, I could be totally bonded with like Instagram and use it all the time, but is it appropriate for me? Is it good for me to do that? And so this is a model that I think is really interesting. I think there's still a lot more work to be done about how do we detect where we're at in this particular stepwise relationship model, and then how do we do adjustments? And that's something that I've been thinking about a bit more. So when we think about building for AI and how we maybe build trust, right? A lot of the literature talks about this idea that certain things lose trust and certain things gain trust. And I've used this model when we talk about teams working together, especially from like a product context, right? And so there's some bar that you believe for a particular dimension that should be the way things work. And that's your expectation going into the interaction with this system, right? Like you may have heard about it. You may have used other systems that are similar. There may be an analogy that you're used to. And so this idea of that below this line, right? It makes you feel less and less trust for a system and may make you want to stop using it. And so things like state communication, making very simple mistakes like we talked about with the complete seating example, doesn't allow intervention, things like that are cases where the system will actually lose trust in the eyes of the person that's using it. But there's other things that are above that are actually gaining trust. And so the question becomes, how are you modulating the trust level for this particular use during the correct types of scenarios, right? So the thing that's tricky about this is that it's actually very, like I said, multidimensional, is that there are certain things you can do in certain cases or for certain types of uses that will lose trust versus the things that you'd want to gain trust on. But it's about the right amount of trust. And next, when we talk about building mental models, some of the things that we've started to use, and these are examples that we found helpful when it comes to how, and these things are not necessarily wholly different from what we do regularly when it comes to user experience, right, or user interface design. So one of these is this idea of an intelligent call to action. So getting people to think about one place where they can always understand what they need to do next, but based on all of the things that are behind it, all these layers of abstraction of the system behind it, it's able to help you be more intelligent as you're doing things. So in this particular case, this is a test of a button that would use that confidence score to decide what it showed people they should do next. One of the next things is really about generating options, right? So if we want to help people understand what they can do, we want to tell them what is a possibility that they can take place, that they can use right now. And so in this case, we did a lot of things around scheduling of different field texts. And so offering different combinations of these field texts was really helpful to people. And so how you do that and how you start to generate more options than what the person would have considered is very interesting to help build why does it do the way it does? Why does it do the things it does? Next thing is trying to understand what the machine's mental model is, right? Like there's this theory that when human beings get to know other people, we start to store a model of that person's brain in our head. It's called theory of mind, right? And so it's the idea that we can understand that someone else believes something differently than us, and that in our heads we can have lots of different people that are out there that all believe different things from us. And so once we start to use machines a lot, we start to build these models. We start to understand what the machine is actually looking at versus not. And so in this case, it was like, why is a schedule being generated by this system? And there's a couple different reasons. Another example is if you've ever used TurboTax, right? It will say that it's optimizing your return to a certain point. It's not actually optimizing your return, right? It already did that. What it's doing though is it's telling you what types of things to consider. And it's trying to mimic a lot of what like a real tax preparer would say, well, I was gonna try to do this, but that didn't work, and then I was gonna do this, or I considered these things. And so they're walking you through a way that really, in a certain extent, builds trust because you're understanding what they thought about through this entire process. Counterfactual examples, so getting back to that actual example, those 4 different types of things. Credit Karma does a very interesting job of saying, if you were to change something in your credit, this would impact you positively. And so it's much more actionable for me, rather than just getting a score, right, for my credit score. I'm actually getting why is it that my credit score is the way it is, and how can I possibly change that? Helping humans avoid errors. So this idea of if you can actually detect errors by people, how do you help them stop doing this? And this is blurry on purpose, by the way. But in this particular case, when we talk about complete seating, we would try to warn hosts before they made a bad assignment. And if they did make a bad assignment, we would tell them why it was going to impact future seatings. So that idea of even before you do the work for them, just helping them do a better job is really, really helpful. And in the end, when it talks about like building a mental model, is that how is it that this machine sees the world such that it's helping me correct my errors? And so this is maybe related to another Don Norman thing, which is cognitive artifacts, right? So the idea of competitive or complementary cognitive artifacts is this idea. If you wanted to use something like an abacus, once you learn an abacus, you can actually do it in your head because you have a new abstraction or a new way to think about orders of magnitude calculations. But if you use a calculator, you're stuck with the calculator. And so the idea of avoiding errors helps train the mental model of the person that is actually doing the work as well. And then being upfront about possible errors. I think this is like when you should and should not use a machine is a very helpful thing. And so, I think when it comes to chatbots, that's why when you first load up some chatbots, they'll say, hey, I'm just a bot, I really don't know what I'm doing. I'm trying to help you, but please forgive me for any errors, right? So this idea of setting of expectation around where errors will be and being more specific about that can help the person build a mental model of where and when they should utilize a system. And then allowing intervention or appeal. So when you build these types of systems, they will be wrong. Like if it's intelligent, it will actually try something that it thinks is right, but doesn't take into full account the human context, and it will be wrong. So what you need to do is when you do set the right level of trust, that is when people will be comfortable actually intervening in some way. And so there's a really great article in The Verge about medical benefits and how that's calculated for people. And so the problem there is that it wasn't necessarily that there was a system that was doing this. There's other issues with that. But the big problem was that the person who was receiving the benefits, the person who was doing the data entry and actually giving the benefits calculation to someone, there was no way they could disagree. There was no way they could intervene. And in particular, they had to take these different companies that built these systems to court in the end. Right? And at the end of all of this, they would just say, oh yeah, that's a bug, sorry, we'll fix that rule. And so the question becomes, how are you setting the right level of kind of trust for your system so that when it is wrong, and it will be, that people can intervene in some way? And then this is related to the feedback, right? So when we talk about how systems get better, I don't just mean kind of like the idea of supervised learning, but just from the standpoint of how are you constantly growing and understanding? A lot of the time, we'll do that through both qualitative and quantitative, but you can actually just ask, right? If someone finds an error or intervenes or does something that you don't really know, this idea of starting to collect this feedback is really key. I think it's something that we should be doing anyways, but it feels like we don't, right? But for machine learning systems in particular, when you need more data, understanding these types of anomalies is really important. So once you actually have built these things, the question becomes how do you test them for this trust? And it's not as easy as just saying, what's the trust quotient that this person has for this particular application or service. What you have to actually do is you have to create scenarios by which their trust is tested over time. And so, one of the things that we did when we were building out all these systems is we started to not only look at things like correct operation, right, which is what usually happens when people build a prototype. It's usually the happy path a lot of the time, right? And so you're testing whether they can actually achieve the end goal. But what's also important is this idea of incorrect operation. And so using the concept of false positives and false negatives, which is something that's really, really important to machine learning classification algorithms, you should be creating scenarios that are testing that it thinks something is right, but it's not, and it thinks something's not right, and it is. And how does that actually impact the trust that they have about that system? You want to be able to test, do they feel comfortable giving feedback? And then finally, do they feel like the information that they're getting from the system as a state is really helpful? And so I've listed out a bunch of different questions, but the things that I think are most important really about this is when you talk about how people feel about a system, understanding and checking in throughout the entire time, like, do they actually trust this system at the beginning? What's their expectation? How do they feel in the middle? And then how do they feel at the end is a really, really important and interesting thing to do when we talk about prototypes. So, in conclusion, I want to, when we talk about the three things that are really most important to take from here is one, provide ways for people to interpret what the machine is doing. It's not just display of data, but it's how are you allowing them to interact with it in a way that is meaningful. Your mental models are not the people's mental models, and even the mental model of the machines, so to speak, is not their mental model, so you need to convey it to them. And then finally, building the right amount of trust is really, really important. And so, yeah, thank you very much. Yeah, and so we'll take questions now as well. How many people have thought about trust in their interfaces before? Okay, cool. Very enlightened group of people.
So if you have any questions, just wait for the mic when you raise your hand, and I'll come over.
How many people actually implement machine learning systems in their products today? Okay, yeah, a few. I mean, what's been the biggest challenges that you guys have had from maybe like experience standpoint? Yeah. Oh.
Hang on.
Sorry, I forgot.
This is a very current problem. So what our product is, we're trying to tell our initial operators what assets are going to fail, but part of that is predicting. And so at first we didn't want to be prescriptive, but now we're learning they want us to tell what's wrong. But then as you mentioned, there's this range of error that we could possibly do, and we don't want to be really wrong. So that's what we're struggling with right now.
Yeah. Yeah, and that's another interesting question to ask when you're starting to talk to different people within the organization is how does failure actually work within the organization, right? Like in some cases when it becomes like if we're talking about autonomous vehicles, right, a false positive is way better than a false negative. And vice versa for things like oncology, like if you get a false positive, you may do something that's very costly intervention. And so not only what is the end human impact of that, like the person that is actually getting the end impact, but how does that then work within the organization? Because some organizations are afraid to fail, right, or afraid to experiment, or even afraid to just double check things. And so anyways, I think that's like a very interesting aspect of that work. Yeah, what else? And questions too, but I'd love to hear stories of like people struggling with this as well.
Hi.
Hi.
The way we are utilizing machine learning is for product recommendations in various different ways of people also bought or bought together, and the problem is
Are you Amazon?
No.
Okay.
The problem is becoming that people buy weird stuff together that is not applicable to others. So while we're implementing different ways to look at machine learning and putting like other variables of like, oh, in the past we've looked at different time periods, we've looked at different product categories, we've tried to bucket people into different profiles, but within the organization, we on the tech team understand that this is a process, but someone on the merchandising team would say, this is weird, this is not what we want, can we give you suggestions? So we're sort of caught in the middle of saying
Yeah.
this is just going to take time, but we want to take their recommendations because we have to like hit certain numbers. So that's kind of been a struggle
Yeah.
to make everyone happy
Well,
and
and, I
explain
mean-
what we're trying to do.
Yeah, no, I think that's a really good point. Is that one of the things that I think is most interesting about recommendation services as well is that we're definitely creatures of habit, right? Like we like to order the same, we like to buy usually the same thing over and over again, and most of the time we don't change brands unless there's a major life event. That's why things like pregnancy, graduating college, like all those events are so important, is because they're like a big time for me to change the way I do things. But most of the time, the idea of serendipity of something new is taxing on me, right? And so I think this gets back to maybe, there's another talk that I've done where the idea of like what is the outcome you're trying to get is something that is very particular. When we talk about machine learning, right? Machine learning is trying to minimize or maximize something. And a lot of the time that does not include the human context, right? So it's about selling as much as I can or automating as much as I can from that standpoint. But human beings are really more about the middle numbers, right? Netflix, for example, Reed Hastings talked about the idea of the biggest competitor that they have for binge watching right now is sleep. And so, and they're winning. And so, in the end, like, it wouldn't be good for human beings to binge watch all the time. And so I think we need to do a better job as practitioners as well as getting to like, what are the actual things that we need? Like for your recommendation service, what are the things that you're really helping people do better in their lives? And that's why when you look at, say, Stitch Fix is one example of they're reversing the model in that I don't have to think about this, right? I get a box once a month and basically I don't have to make a lot of decisions. Versus Amazon, the idea of subscriptions, it's more, and their buttons and all that, all that type of stuff is trying to get to a better place there. So I don't know, I think that's where trying to understand your customer's mental model about the way that their world works for purchasing things is really, really important, right? Yeah.
Two unrelated questions, but one of them has to do with Stitch Fix. So Stitch Fix, it produces an action which is ships you a box, right? And you're wearing Stitch Fix.
Yeah. I mean, I look pretty good, right?
I think you look fine.
You don't.
Yeah.
It's okay. You don't have to say.
So the question there is like, so the AI sends you this box, right?
Well, actually, so it's if you the talk is really great if you get a chance to watch it, but it's about both, right? So the AI
Which talk?
The Stitch Fix talk that I referenced by
Okay.
Brad,
Yeah.
the VP of Data Science, and so in that particular case, it's actually the machine learning algorithm is offering, based on everything I've done previously, things like sizing, things like style, preference. There's like a profile of me that's there, right? And so it then provides a list of things to the stylist, and then the stylist actually has to make the human judgment about whether it's correct or not. And what they've said that is most interesting to me is that it's actually the extreme cases that are hard, right? So in the case of like Napoleon Dynamite, who likes Napoleon Dynamite? That's a very hard question for Netflix to answer based on your previous watching record, right? Same thing with Stitch Fix. For people that are really extreme in their fashion, there's really no way for a machine learning algorithm to understand that context, at least today, right? And so that's the way that they think about it.
So would you say they get their predictions, like, would you say they're I mean, you put in your profile,
Yeah.
right, your style and what a preference is, and perhaps what profession you work in and
Sure.
stuff. And they sent you a box. It's a very finite thing they sent, shipping included.
Yep.
And it just seems like the probability of getting something like that wrong is very high, and it's
Yeah,
very
it is.
expensive.
But the cost of that is very low, right, to me. So it's maybe a good example is like spam filtering. Like spam filtering is something that has employed a lot of different techniques, including machine learning, to get better at, right?
Mm-hmm.
But the cost of it in certain cases is very low. In other extreme cases can be very high. So, and this is, there's someone just spoke at his first name is Kush, I'm blanking on his last name, but he's from IBM Research. And so he's talking a lot about this idea of that when you're talking about your optimization function, in some ways, the actual environment of your space may have different levels of outcomes based on where you're making errors. And so certain errors may cause really bad value effects versus others will not matter at all. And so like the idea of your boss's email that's urgent going into your spam box or being deleted automatically, that's very bad. But for like the 90% of the emails that you actually get on the internet is spam, and you should never see.
So what I'm hearing is for a mass market population, it works well.
I think in some ways. I mean, the thing that's interesting is that I don't know whether they do segmentation from the standpoint of that we are all kind of like complex. Well, we're all very simple, right? But we're also we have segmentation inside of us, right? So like this is my kind of outfit for speaking at a talk or something like that, or dressing up for like a work meeting, but I'll usually wear like a black t-shirt and jeans, which is my regular stuff, but then that's different from my weekend. And so the idea of that we are in some ways conflicting, like I want to be styled in certain ways during certain times, but that's a very hard context to get at, right? And so I think there is definitely a failure case here. Like there's been a couple times where I've sent back whole boxes, right? And so it's definitely something that you really have to understand what the end use case is. And when I talked to this VP of data science at Stitch Fix, it was really interesting because he was talking about how he actually needs to reduce randomness in some way. When the reality is when we do creative work, we're trying to expand randomness, right? So the idea of a stylist that is, maybe between different stylists, they all have the thing that they like, right? And then they're using that as a lens to decide how to recommend things to me. And so that randomness is good in some ways if I match with that stylist, right? Which is something you can do with Stitch Fix. But it's bad if that stylist is trying to push some like style agenda on me, basically. And so it's very hard. It's a very hard problem, right? Like it's very hard, especially style. Like there's a whole thing about how do you understand this idea of the space of embeddings for style? And how do you convey that to a stylist is a really, really hard abstraction problem because it's not just two dimensions, right? It's not whether I like, zebra print or not, and then shorts or not. It's like
aesthetic point of view. So
well, yeah, and there's many, many dimensions that they're collecting right now, and so it's a high dimensional space that they're trying to give to the. Yeah. Anyways, sorry.
And not to hold the mic, but another question: how do you apply graph theory to AI?
Well, so graph theory is really interesting. The work that I helped out with was a lot about fault-tolerant graphs, and so the idea of like network routing and that type of thing. But I think what is most interesting is basically whenever you do things like textual analysis, you need to understand the entities that are existing within it, right? And from that standpoint, you need to have a knowledge graph as a starting point, or you need to assemble one. And so when you do a lot of the NLP, when you use like NLP services that are off the shelf from like Google, they're using their knowledge graph, which is if you type something in and it comes up with like a very specialized result, that's part of their knowledge graph, right? Now the tough part is that we've tried using that for doing different types of analysis. Like we tried to do analysis of our Slack channels to understand whether customers would buy with us again, right? And the truth is it didn't do a good job, right? Another place where we're experimenting with NLP is this idea of doing automatic transcription of interviews that we've done, and then turning that into synthesis in some way. And so, the example, we use a service called Temi, which is pretty good, but we did a lot of work for Prudential where we were focusing on benefits, and every time someone said 401k, it came out as FOUROH1K question mark, like every single time. And so that's the issue with a lot of these things. The jargon that's involved is not captured properly by these types of graphs. But maybe the future-looking thing is what's most interesting about the idea of knowledge graphs is that at some point when we talk about creativity, right? Creativity is about the combination of ideas. And if you believe something like adjacent possible, which is this idea that we're constantly moving outward in some type of graph of understanding, and that you have to take one step to get 10 steps to start getting 10 steps away, that is really just a knowledge graph of ideas. And so that to me is really, really interesting. And I'm happy to talk about that more afterwards, but yeah.
Hi, I sort of want to ask a question that you briefly mentioned and sort of tied back into the machine learning part. You mentioned something about dashboards.
Yeah.
And so I do a lot of work with data visualization in different contexts.
Yeah.
From sort of the more New York Times-y example that you gave that's very custom to the more formulaic,
all
generic
of the
dashboard
RPN graphs
everything in one space, right? And then the other thing I want to sort of tie that into is with your examples of machine learning and AI approaches, right? So everything from regression through decision trees to very abstract neural nets.
Yeah.
When you're building a product for your clients or building consulting for clients, whatever it may be, how do you use this idea of data visualization or techniques in that sort of expansive world, again, from one end of dashboards to the very custom, and sort of build these models visually for people to make decisions and to change these very abstract ideas, from often very mathematical ideas, into something that's tangible for people, and especially the idea that you keep on bringing up about building a mental model. And how do you approach that?
No, I think, I mean, in that particular case, it's what do they need to do with the data, right? That's the key aspect, because your dashboard or your like service exists within a whole bunch of steps, right? It's not the only step. If anything, like if you want to get, you can get more and more meta about it as far as, including more and more, but service design is right about a lot of this stuff, right? That your offering exists within a larger context. And so the question becomes, how are they getting to your service or site or app or whatever it is? What is their mental state when they're getting there? What is it that you want them to now take action on? And then where do they go from there? And so from that standpoint, dashboards, I think, are more likely to be safety blankets for executives because it makes you feel like you know what's going on, but you're not actually taking any action, right? You're going there and you're like, I'm getting this email, and it's like, oh wow, the numbers are up again, that's awesome. Or the numbers are down, why is that happening, right? Like, but in the end, it's more about like, how are you helping them make a decision? Or how are you helping them move on to the next step of their life? And so in that particular case, when we talk about visualizations, what's really, I guess what I've found is that the concept of like skeuomorphism, right, is a really important one. Because we did a project where we were working for a theatrical booking site that was doing, basically taking Broadway shows off Broadway in the United States, right? And so it's a complicated scheduling problem. There's a lot of contractual stuff. There's prediction about revenue and everything, like what's the optimal route, all that type of stuff. But they used effectively 10 spreadsheets to do this today, right? There's a lot of copy and paste errors. What blew their mind was that we could integrate truck mileage with a particular website, and so it was like, that was an easy win for us. But what we really did is we made it look like the spreadsheets that they had already been using, but they were much better than that, right? So I think when we talk about skeuomorphism as a way of that like connective tissue between where you are today and where you want to be, right? That's what skeuomorphism is meant to be. It's like a mental model that you're using that is kind of, you can discard later, but it's something that you're taking them towards those steps. So I think maybe the biggest problem that people end up doing is they end up thinking too far ahead, right? Like they end up thinking about what this end state is 10 years in the future, when the reality is you need to be talking about like every release up until then. And so starting from that standpoint means that you can start to evolve mental models rather than building one monolithic mental model. And I think that's maybe one way to think about it.
All right, we'll make this the last question.
How do you see the application of these concepts in industries like healthcare that are exceptionally regulated?
Yeah.
And a lot of our discussion is how can we use AI to make the human interactions much more informed,
yes,
more customer-centric, so that we get our patients more adherent to medications. But we have a lot of restrictions on what we can collect,
that's right,
how we can use it. We have a lot of factors around income. We have disease states that are essentially diseases of the poor.
Yeah. And
there are a lot of restrictions and fear around how would you use information, and are you treating people differently? Is it, what does that look like? So I'm looking at this and I'm getting excited, but I feel very sad as well. I mean, can I have this too?
Yeah.
So what is your learning around regulated industries?
I mean, I think one of the things that we do during the empathy mapping for the machine is this like think part of the machine. And a lot of that is, a lot of the time when we're building these systems, we usually start or try things like expert systems where we have heuristics that do things, right? What we need to do, and one of the things that's interesting about machine learning systems is that if you don't set the right, like the loss function or optimization function or just like outcome, if you don't set that correctly, it will try to, with all of its might, overcome whatever heuristics you put on top of it, right? Because that's what it knows to do, is it knows how to minimize or maximize. So I think the thing that we need to do a better job of, and maybe this is related to that, is that we need to include those things in how we set the outcomes, right? Because the regulatory environment is not something, like maybe a good example of this, right, is when I first started working, when I was at Waze, for example, right, we did a lot of business development deals, and a lot of the time I would get pushback from legal about doing certain types of deals. And the reality is that legal is there to help me, just like engineering is, to make a trade-off call on what is valuable right now, right? It's not the other way around where legal tells me what to do from the perspective of that. Now, things like HIPAA and other medical regulations are things you must do, but it still comes down to a risk profile, it still comes down to a trade-off. And I think the biggest concern, especially for these highly regulated industries, the reason why they're highly regulated is because the stakes are very high, right? If you make a mistake with someone's medical care, you could kill them. And so I think this is where things like simulation are very interesting, like the idea of modeling people, trying to understand that, still making sure that the human being has as much of a role in intervening when they need to, right? So it's that these are tools, these are things that are helpful, but it's really how are you still making the human at the center point of that? Because when you talk about like the decision to go on palliative care, right, is a very, very hard one. And so not only is it all the doctors need to weigh in on their thoughts about whether that's necessary or not, but it's about all of the family members that are involved in that decision too, maybe, right? And so if you focus on the humans, I think you'll do a much better job at all of these complex things. The regulatory thing is just something that like, it's like how you CYA when you need to, type of, you know what I mean? I don't think that's very satisfying because it's just hard to do work in healthcare because of that. But I think focusing on the human, and that's where a lot of this like, you know, a lot of the things that healthcare is going after, outcomes rather than treatments, right, is the right direction to go. So, cool. All right.
Thank you very much.
Thank you, everybody.
Chris. Thank you all for coming tonight. Thank you to our volunteers who helped to check you in tonight and help us set up. I want to let you know about a couple of events that we have that are now posted on Meetup, so you can sign up for those now. We will have another bonus event coming up later this month on October 23rd. That event is going to be held at our sponsor space at TCG. So that space is near Grand Central. And we'll have Abe Rubenstein, who's a senior software engineer who leads development of Enigma Public, talking about bizarre insights that can be gleaned from public data, and he will also discuss techniques to uncover your own treasures. And then on November 6th, next month, we will be back here at Workbench, and we'll have Laura Laterman from Measure of America talking about harnessing data and design to improve communities. She'll talk about a report that they put out called A Portrait of New York City 2018, Wellbeing in the 5 Boroughs and the Greater Metro Area. And she'll also discuss working with partners to identify data and research needs to lay the groundwork for policy changes. So I hope to see you here or at TCG in a couple of weeks. There may still be a few slices of pizza left and some cookies, so please stick around for a little longer and meet somebody new, finish up the food, and we'll see you soon. Thank you.